All right, section 5.2, the law of cosines. So I put a box here around the only formula you really need to memorize because remember the letters don't matter. What matters is what the letters represent. So if you remember, law of cosines is when we have a side, an angle, and a side, and the angle is between the two sides. Then whatever the angle is that you're working with, that letter is going to be different than the letters of the sides. So you'll notice here we have cosine alpha with side B and C, or beta with side A and C, or gamma, or you can call it angle C, with side A and B. And whatever the two sides you're using here, it's just going to be one side squared plus the other side squared minus 2 times the sides multiplied together times the cosine of the angle. And what that does is you're finding the side across from that angle. You can't use law of sines with a side angle side triangle because you don't have any pieces that are across from each other. So this allows you to find a side across from the angle, and then you can use law of sines to solve the rest of the problem if you choose to. We can also use law of cosines to find angles if all we have is the 3 sides. So the angle that you find depends on what order you put the sides into the problem. So if you're trying to find angle A, then you're going to do side A minus side B minus side C divided by negative 2BC. If you're trying to find angle B, then it would be B squared minus A squared minus C squared minus 2AC. These letters will match those. If you're trying to find angle C, then it would be C squared minus A squared minus B squared minus 2AB. So this formula that I've written here just came from taking this formula, subtracting b squared, subtracting c squared, dividing by negative 2bc, and then doing the inverse cosine to find the angle. In the book, they've written the formulas this way. I would recommend instead of memorizing them, just make sure you understand how the formula comes from the original formula, and then you're good to go. Now, these formulas are not really different than mine. All that they've done is taken the negative from the denominator that you've got here, that came from here, and distribute it through the numerator instead. So take that negative, multiply it here, make that negative, make that positive, and then switch the order. I don't know why they do that. It just makes it look better. Just wanted you to be aware that these are the formulas in your textbook, but this is by far, I think, the easier way to just deal with it because it comes directly from the formula without any weird little tweaks to the negative. Okay, let's look at our first example here. Now, I did this earlier and made a mess of it, so I promised I would redo it. So that's what we're going to do right now. So let me clear this out. So we have the fact that we can use a triangle for side angle side. We can use law of cosines to solve side angle side or side 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 problems, which is what I just talked about. So let's do example 1. We're going to solve the triangle given beta is 50 degrees. Notice this picture I put here for you has both the beta and the b. Kind of the b is representing the point and beta is the angle, but we could also call it angle b. And then c with gamma. A is 7, side C is 2, and angle A would be alpha over here, side B here across from beta. Now be careful, this picture might throw us off because the way that I've drawn it in with the labels, it looks like C would be the longest, but if you look at the actual numbers, C is the shortest by a lot. So 7 is quite a bit bigger than 2, meaning that angle A is quite a bit bigger than angle C. So that's going to be important here in a few seconds. Okay, the first thing we're going to do is use law of cosines. So we want to find side B across from angle B or beta. So we're finding b squared equals a squared plus c squared minus 2ac cosine 50. So to find b, we're square rooting the whole thing, correct? So we're going to have a squared, which is 7 squared, and we're going to have c squared, which is 2 squared, and then we're going to go minus 2 times 7 times 2. The reason there's a 2 twice is there's a 2 in the formula and there's a side length 2. And then we'll have the cosine of 50 degrees. Make sure your calculator is in degree mode. Chapter 5 is kind of all about degree mode. So we throw that in a calculator. Be careful, depending on your calculator, it's hard to put things in properly to get the right answer. We end up getting the square root of 35, which is, because we're doing 49 plus 4, and then minus this times this. Make sure you multiply this together before you subtract it. So square root of 35 is approximately 5.9 units. So definitely notice how the 2 is smaller than the 5.9 or the 7, making this angle definitely the smallest, and this would be the medium-sized angle, and this one would be bigger. Now, my concern with 7 being so much bigger than 2 is that angle A, or alpha, is probably obtuse. And if it's obtuse, then we're not going to be able to find that directly from law of sines without doing some tricky stuff, because using an inverse sine will give us a quadrant 1 angle, and an obtuse angle is in quadrant 2. So we can do that just by understanding reference angles. However, just to avoid that, you might notice that in example 2, I said, note, solve for the biggest angle first, just in case it's obtuse. Biggest angle is across from the longest side. Now that is a note for example 2 for using law of cosines. When you're using law of cosines, solve for the biggest angle. But in this case, since we might want to use law of sines to do the next step, we want to use angle, we want to find angle C first because it's definitely acute instead of angle A, which is possibly obtuse. So let's go ahead and find angle C. So to do law of sines, to find angle C, we would do sine of C over 2 equals sine of 50 over 5.9. If you want to avoid rounding errors, you could use more decimal places. And then I'm going to cross multiply and do inverse sine. So C is going to be the inverse sine of 2 times the sine of 50 divided by the sine, nope, divided by 5.9. So we put that in our calculator and we should get a reasonable answer. I don't remember what we got the first time around. Let me pause. All right, I put the numbers in my calculator and I got 15.05 degrees for angle C. So now for angle A, all we have to do is take 180 and subtract 50 plus 15.05, which gives us 50 plus 15.05, 114.95. Okay. Now, those of you that were actually part of our video chat today saw how we tried to find angle A first, and we got like 65 degrees, which was wrong, because that was a quadrant 1 angle, and we needed a quadrant 2 angle, so we had to subtract 65 from 180 to find the 114, and then we found angle C. So it just works easier if in a situation like this when you're using law of sines, make sure that when you're using law of sines that you're not trying to find an obtuse angle.